For more than 100 years, there has been increasing interest in these caves by people from all segments of society. After Walter Birch found the additional chambers and rooms, he and a partner opened up the caves as a tourist attraction. And as interest grew, so did people's intellectual curiosity. Thomas Condon was the first resident geology professor at the University of Oregon. His public lectures about the geology of the region attracted large crowds into packed halls in the 1890s. The caves were one of his favorite subjects and a popular destination for college students on his class field trips. You can see many of their signatures on this formation known as Niagara Falls. Today, this historical graffiti provides us with a clue about just how this cave and the flowstones in the cave were formed. In Condon's time, the prevailing theory of how limestone and marble caves formed was that rock and sand carried by groundwater scoured out the caves. While some features, like these intriguing cusps, known as cave scallops, were created by the physical force of flowing water and abrasive rock, most are actually the result of chemical processes. The Oregon caves formed in marble, a calcium-rich rock that dissolves if exposed to acid. The key to the creation of the caves is the forest above. Bacteria and other organisms in the soil release carbon dioxide, which mixes with rainwater and melting snow. This combines with water to create a weak acid called carbonic acid. As gravity pulls groundwater downward into the rock, over the eons, this trickling solution of water and acid slowly dissolves and opens up cracks and crevices in the rock, creating maze-like catacombs large enough for adventure-loving humans to explore. But what creates the fantastical formations that inspired Fiddler's poetic descriptions and Condon's intellectual curiosity? When water with a high solution of carbonic acid reaches an open air pocket in the cave, a reversal of the acid-calcite chemical erosion process occurs. Instead, the now calcium-rich water creates calcite flowstones, often with spectacular results. It happens like this. As water contacts the air, CO2 in the water bubbles off, and the carbonic acid dissipates, leaving water that is supersaturated with dissolved calcite. As the calcite falls out of solution, it builds up hard surfaces to create flowstones, such as the strange and eerily beautiful stalactites, stalagmites, and other cave decorations that excite our imagination. Geologists of Thomas Condon's generation knew that flowing water created cave decorations, but not how long it took for the deposited calcium to form calcite flowstones. Ironically, Condon left us a clue about how this process works when he and his students left their signatures on this formation in the 1890s. When the monument staff attempted to erase the signatures some 20 years later, they could not. A thin layer of calcite varnish, about the depth of a fingernail, had covered all the names.